Okay, so like I just said, I forgot to record it, so I'm not going to have the full-on explanation for the angle of elevation and depression, but the main thing you want to take away from it is that angle of elevation and depression both move off of a horizontal line, never a vertical line. Depression means to depress below the line, elevate means to elevate above the line. Okay, so let's take a look at example 1. It says, from a boat on the lake, the angle of elevation to the top of a cliff is 20 degrees and 42 minutes. If the base of the cliff is 1,394 feet from the boat, how high is the cliff to the nearest foot? So the first thing you want to do, what do you think? Draw a picture. Yay. Yeah, so we're going to want to draw a picture of this. Hold on, my screen is not moving. I know your screen moved, but mine didn't. Huh. This is going to be tricky. Oh, there it goes. Okay. So, oh, I just lost it. Did you guys just lose it? What is happening? I don't even know how to scroll on this, though. I'm not sure.
Oh, you got it. Oh, there's a mouse on the right.
Okay, it's going, I can't see what it's doing because it's got a delayed reaction. Oh my gosh. I'm going to have a heart attack. Hold on. Maybe it will be easier. I know I did that on the computer, but now I have to wait a second for my iPad to adjust with it. So give me a second. Did it just go away again? No, mine is showing a completely different page. This is very frustrating. Okay. Okay, guys, I think I'm ready to go. I think I've got it on here. All right, ready? So we've got a boat on a lake, and then we're looking up to a cliff. So I'm going to start by drawing. Oh, no. Okay. This is getting stressful. Did it do something up there? All right. Here's your cliff. Yay, it worked. Okay. I'm even going to get to do this in color coordinating now. Here's your lake. We're going to do a pink ship. Okay. All right, so we've got a cliff and we've got this boat out on the lake, and it says that from the boat on the lake, the angle of elevation to the top of the cliff is 20 degrees and 42 minutes. What line should I draw in order to illustrate that angle? Yes, indeed. Okay, but which angle is it? So is it, oh, I can do this on here. Ready? Where's the arrow? Is it this angle, or is it that angle? The other one, right? Okay. Now, I'm not going to put in 20 degrees and 42 minutes. Why not? If I want to do stuff on the calculator with that degree, it needs to be in decimal form, right? So what I need to do is figure out what is 20 degrees and 42 minutes as a decimal. What's the computation that you do for that? I'm sorry, you do what? I just heard multiply by 60, I heard divide by 60. Which one is it? Divide by 60. Yep. So you will divide by 60 on that. That will give you 20 degrees. So that's the degree measure that I'm going to go ahead and put in my diagram. Okay? All right. What else do we know?
1,394.
Which distance is that? The cliff? Yep, the blue line. Good. So that's 1,394. I know. All right. We're assuming that this is forming a right angle, right? Assuming. Okay. And what do we want to find? Which would be that guy. This one should be a pretty basic setup. What are we going to do? Yeah, tangent, because we're given an acute angle and then we're working with two sides. So if you're looking at this from the perspective of this angle, you've got an opposite side and an adjacent side, TOA, tangent. So we'll write the tangent of 20.7 degrees equals opposite side x over adjacent side 1394. So that means that x is going to equal 1394 times the tangent of 20.7. Make sure that you're in degree mode, right? What do you guys get as an approximation for that? What is it? I don't think it's to the nearest foot. What?
526.7.
Point.
75.
Okay, now read the directions. It said to round to the nearest foot. So what is the nearest foot? And we're done. Easy enough, right? All right. The next type of problem that you guys will have are a navigation problem. So let my computer work on moving the screen down again. Uh-oh.
Why? What is this?
It's not letting me. I don't know, because that'll take it completely. Oh, yeah, maybe you're right. But then we just lost all that. Save it. So these might go in as separate videos then. I'm not entirely positive if it will or not. Okay. And we're ready to go again. All right, so this one says the bearings of 2 points on the shore from a boat are 115 degrees and 123 degrees. Assume the points are 855 feet apart. How far is the boat from the nearest point on the shore if the shore is straight and runs north to south? So one thing that you have to know about navigation, when they're talking about bearings, they're always talking about moving from the north-south line in a counterclockwise direction. Okay? And you'll just kind of have to figure out how they want it drawn. So for this one, it says the bearings of 2 point on the shore from a boat. And I think, yeah, it says it kind of far at the end of the problem, but it says we're assuming that the shore is straight and it runs north to south. So I'm going to assume that my shore looks something like that, right? And I've got 2 points on the shore that are the bearings of 2 points on the shore from a boat. So here's my boat, let's say. Okay. Oh no. Why won't it let me do another boat? Okay. It's going to sink pretty quickly. Yeah, that one is going to sink pretty quickly, I think. Yep. And I think I might have drawn my boat too high up because I need it to be on a bearing of 115. So I'm going to redo that boat. I really kind of want my boat down here. Reason for that is I want my measurement from the north-south line to measure out to be 115 and 123 degrees. So in other words, it needs to look something like that. Oh no. Okay, starting over. Hold on, because I know what I need to do. I'm just learning how to do this, so patience. Yeah, so you guys are going to have a lot of fun watching this lesson because it's all me trying to figure this out. You don't have to watch it. It's just if you want to go back and, like, if you forgot something I said in lesson or if you're absent, you can watch the lesson if you need to. You do not have to watch it. Yeah, if this works. I'm not sure if this is going to work, so we'll try it. All right, so I'm going to try this again. I've got my straight shoreline. Okay, I've got a boat. And I'm trying to draw a couple of points. So what this means is that one of my bearings, and you can see that my larger angle is up here, so that's going to be the one that's 123 degrees. So the bearings means that you're measuring from the north-south line, and you're measuring out that degree to the object that you're talking about. Does that make sense? Any questions on that? So from the north-south line, measure the angle that you want out to the object that you're talking about. Cool? So then this one angle down here is 115 degrees. So it just says that you've got two different points on shore, one that is a 123 degree bearing, one that is a 115 degree bearing. Yeah?
Is that from the inside or the outside of the Like,
It's in the angle that I'm showing. So 115 degrees is the obtuse part. So from the north line, right, measuring 115 degrees this way. You can do it from the south. Like if I had drawn this picture, like, and I'm going to erase it in a second. I could have drawn the bearings south. So I could have drawn like this. It still would form, like this would still be the 115 and this would still be the 123. So it would still be the same case. Does that make sense? Okay. All right. We need to find, and then it says, what else does it tell us? Assume the 2 points are 855 feet apart. So we're assuming that this is 800, oh my gosh. You guys can't see what I'm having to deal with up here. It's not going well. My handwriting isn't going to be as nice as it usually is. Okay. You've got 855 between those 2 points. And then it says that we want to see how far is the boat from the nearest point on the shore. What they mean by that phrase is not the nearest point that you're given, it's literally the nearest point that you can possibly find on the shore. So in other words, they want to know what is the perpendicular distance from the boat. That guy. That forms a right triangle then. Okay. Now what I'm going to do is I'm going to redraw this picture, the triangle part of this picture bigger so that we can kind of deal with it a little bit better. But this is the sketch that you're getting. Do you guys see that? So really the picture that we're dealing with here looks like this. Whoa. Okay. Uh-oh. Is that what I wanted to do? 15, yeah, I think so. So if this angle up above this one, so if we're looking at the original picture, if this is 123, what is this guy? What? 57. So I'm actually going to take off the 115 because I'm going to want to get the other part. So this is 57. And what's this guy? Okay. Do you guys... So I had to find those acute angles because I really want to be working with the angles inside the right triangle. So I took the 115 and the 123, and I figured out, okay, that means that my acute angles are these two. Okay? I still know that the distance between the 2 points, so from, from here to here is 855. Oh, sorry. Let me redo that. I'm trying. 8, is that a little bit bigger? Okay. And we are ultimately looking for, that guy. Okay, here's the trick. And you have to be able to put it in yourself. The trick is that you need to use the 2 right triangles, and you aren't given everything you need on the smaller right triangle. So what you're going to need to do is put in another variable, because we don't know what the distance is, but we know we need to use something there. So I'm going to put in a y. So when you're given a situation like this where you have a right triangle with kind of another smaller triangle embedded in it like this, you're always going to be writing, you should be given one of these chunks. So you'll either be given this chunk or this chunk. And what you want to do is put a variable in the other chunk. And most often you're finding the side that's not being split up, usually. Okay, so this could be given to you just like, not in a word problem form. I might just give you the triangle and say solve for this missing piece, or you might have to construct it off of the word problem like this. Okay? The main thing is that now you have to figure out how to do the setup on this, and that's where things get extra fun. Ready? Whoa, that was not, that's all you have to do. You're done. Just kidding. All right. So what you want to do is set up 2 trigonometric functions. So you can set one of your trigonometric functions up using the big triangle. Yikes. Whoa. All right. Using the big triangle. And then you can also use one using the small triangle. Right? Okay. So if I'm going to set up a trig function using that big triangle, which angle should I use? 57 or 65? 57. Which trig function can you use with that angle and what you're given? Yep, tangent. So what you can write is that the tangent I know. It goes to sleep sometimes. Now I have to see if it's gonna. Can you see it? Okay. So I'm just going to try and write a little bit smaller is all. Okay. So we can write that the tangent of 57 degrees is equal to the opposite side. How are you going to write the opposite side for that, though? X. Yeah, sorry. All over, and how are you going to write what I meant is the adjacent side? Is 855 plus y. Very good. So that's one of the equations that we can work with. Okay, the other equation that we can work with is the tangent off of 65. What is the tangent off of 65? Yep. Okay. Which variable do you want to solve for? X. Well, eventually you want to know what x is, right? So the idea is that you've got 2 equations with x and y. What you're going to do is solve both of the equations for the same variable and then link them through substitution. You'll see what I mean in a second. The main thing is that you don't want to link the x's because then you're going to lose the x's. Okay? So what you want to do is solve both of the equations for y, and then you'll have y equals something in terms of x and y equals something in terms of x. So the 2 y parts can equal each other. You'll lose your y's and have 2 sides equal to x. Okay? If you solved for x and then linked them, you would lose that x, and then you'd be solving for y, which isn't really what we care about, right? Okay, so what I need to do is solve both of these equations for y. So for the top one, where am I going to go to do this? Dun, 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 dun. I'll move down here. Okay, so for the top one, you're going to multiply up by the 855 plus y. So you're going to have tangent of 57 degrees times 855 plus y equals x. Now that looks nice because you're like, oh, I got it for x. But again, you don't want to lose your x, right? So we need to switch it over to be in terms of y. So that's pretty straightforward. You're going to end up distributing the tangent in. Well, actually, we can do this a little bit simpler, can't we? Yeah, let's just divide by the tangent. So you have 855 plus y equals x divided by the tangent of 57. And then all that we have to do is subtract off that 855. So that's one of my equations that I can use. The other one's actually going to be a little bit easier. So for the other one, if I were to multiply up by y, I would have y tangent of 65 equals x, and then to get y alone, y equals x divided by the tangent of 65. Now I've got two things that are y, so I can set them equal to each other, right? So I'm going to set x tangent of 57 minus 855 equal to x over the tangent of 65, because both of them are equal to y, so they should be equal to each other. Okay? You're trying to isolate x, so how do you do that? You don't have to do that. I would not even worry about the fractions right now. I would get my x's on the same side. So I would do x over the tangent of 57 minus x over the tangent of 65 equals, and then add over my 855. I'm running out of space. That's a problem. Do you guys not see what I'm doing?
No.
You? Why did I put the x's on the same side? How am I going to use the fact that the x's are on the same side? Take them out. Uh-oh. What just happened? Forward. Okay, hold on. Nope, that's not what I was trying to do. Okay. So I'm going to start working up in this space. So yeah, the whole point of that was that I could take an x out. I'm left with 1 all over the tangent of 57 minus 1 all over the tangent of 65. You could write those as cotangents. When you punch it in on your calculator, you're going to end up doing 1 over tangent anyway to get the cotangent, so you may as well just leave it, if that makes sense. That equals 855, and then we're going to divide by all of that. So you're going to have that x is equal to 855 divided by 1 over the tangent of 57 minus 1 over the tangent of 65. The main thing to watch with this is that you're punching it into your calculator with parentheses in the correct places. So I would almost do, I would do 1 divided by the tangent of 57, end your parenthesis on that, and then subtract minus 1 divided by the tangent of 65. end your parenthesis, hit enter, you should get 0.183. Oh, wait, no. Yeah, there you go. Because I think I'm in degree mode. Make sure you're in degree mode. That's the other thing. Okay, and then you'll do 855 divided by that answer. That is 4,669. So x is about 4,669.58. This is the type of problem that you need to be able to do on the quiz.
Wow.
I give you the drawing, so that helps a little bit, but you don't have to come up with the drawing on your own. I give the drawing to you, but you need to know this process of if you have that triangle embedded in another triangle. No. I didn't really color code on this one though. I only used a little bit of red. Oh, just a tiny bit. Okay, you ready for the homework?
Yeah.
Okay, this is, hold on, let me see if I can do this correctly.